Okay, hello everybody. I'm David Blevins, so it's really fantastic to be here. I'm a kind of local up in Los Angeles, so it's good to come down and speak nearby. We've been there for about 13 years, so it's pretty cool to speak locally. Actually, I haven't spoken at the Los Angeles Java user group yet, so you beat them.
Yay! No.
Oh, absolutely.
Okay, everybody, come on, give us a good wave. Something, yay! Thank you.
Awesome. Twitter.
That's it.
Okay, so as Paul mentioned, we're a startup, and we deal with a lot of customers who try and throw hard problems at us. They haven't managed to get solved elsewhere, and we have also been working on an app server called Apache TomEE for a very long time, and we're generally back-end people, and we do support for that kind of stuff. And so we had a big customer of ours ask us a couple years ago, right, we just rolled out TomEE, now how do we secure it? And it was like, basic auth? And of course that doesn't really fly. So we did a lot of research, and having participated in the JavaEE standards in the JCP for a very, very long time, on many specifications, one of the things that you become familiar with is that there's always somebody in the specification who doesn't like the specification. They don't like where it's going, they get really, really mad about it, and sometimes they eventually leave. And so what we did to try and get up to speed in the space of security as quickly as possible is look at version 1 of the various specifications, like OAuth 2, and there's another one we found called HTTP Signatures. Look at the current version, see whose names were not on the spec anymore, contact them, ask them what they thought about the specification, and then of course they can't stop ranting about all the things that they think are wrong with it. Now, obviously it's going to be biased towards their perspective, like the spec lead is going to be biased that everything's perfect, but you combine the two perspectives and you usually get a pretty good thought. So we gained a lot of maturity in this space really, really quickly, and we eventually did end up making a security product, but that was an afterthought. It was like, what are we going to do with all this knowledge? But we put this talk together, I put this talk together really because I don't think there are a lot of talks about security that are given by people who aren't already security experts, written for people who are already security experts. It seems to be the case that every time you see a talk about security, the person goes straight into the deep end and goes, so in the latest, SHA 256 is, of course, we all know, much more secure than 120, which you shouldn't use. We all know that too. And so they really, it's very hard. So I tried to put together a talk that shows you kind of an architectural perspective of how these things play out in practice, and the most fundamental concepts, and to really strip away all the fancy terminology. Because that's like one of the worst things about the security standards, because there's so many of them. I think that this is one of the hard things about learning security, is because you start reading one of the security standards, and it gets halfway in and it's done. And then you're like, wait a minute, where's the rest of this thing? And then there's like pointers to other security standards. And the more you read, the less you feel like you're learning it, and you feel more confused. Like, you have no idea when you're going to be done, because every time you get to the end of the specification, it goes, and of course you've already read this, and you know all these things. And so you go to read those, and you find out you're like in a maze. And you're like Groundhog Day. You're just doing the same thing over, and so it doesn't help. This world could be so much simpler if we didn't rename all the things that already existed every time there was a new security standard. And everything has to have a new name, because of course if you're a spec author, I guess you're getting paid by the page, so you have to have a lot of pages. And I've learned, at least like reading through the OAuth kind of specifications, the OAuth 2 specification is an architectural concept. There's nothing very little standardized in it. Then you have other specifications for JSON Web Tokens. They always follow the same pattern. There's an introduction boilerplate. There is the end, which is like the same standard references to other specifications, and only the middle third is actually any information. it's a crazy waste of time. So what we're going to learn in this in this talk is basically we're going to take a look at where we're at now, which is basic auth and that kind of world. We're going to see how that pans out architecturally. We're going to look at OAuth 2 in its original incarnation, and then we're going to take a look at OAuth 2 with JSON Web Tokens, and we're going to look at another specification called HTTP Signatures, and thankfully we have 2 hours tonight. We're going to look at another thing that kind of combines JSON Web Tokens and this message signing approach. So effectively, I like to describe the world of security that's going on right now. There's kind of 2 camps. One is a big majority, and that's the JSON Web Token camp. That's what Google's doing, what Facebook is doing, and things like that. But Amazon, they use message signing. So these are a different approach, and we're going to show what that is. So they're securing their B2B business. All your AWS calls, REST calls, over the client API, all are using message signing, which is totally different than JSON Web Tokens. So we're going to see both worlds, and we're effectively going to see how to combine them. So that's the high level of the talk. So let me just quickly get a litmus test in the room. So who here writes any apps that have users? Okay, and that was just a test to see if your hands work. So I've now calibrated the room. 70% of you are going to answer questions, since 30% of you are not. So 70% is 100%. Calibration achieved. Okay, basic auth. All right, that's fine. It's better than no auth. So, no auth. Okay, all right. Yeah. Who doesn't have any users in their app? It's a perfect app. It's always secure. No one's ever going to break into it. No bug reports. Yeah. Perfect. So SAML tokens. All right. Kerberos. All right. Who's using OAuth 2 or OAuth 1? Okay, OAuth 1, we got some hands. All right, and N2? Okay, and JSON Web Tokens? 3 hands, all right. This is a good talk for you guys. Okay, anything else that I didn't mention? Who wrote your own security? Okay, all right. Okay, so, our base architecture, because I think that these types of talks are really hard to follow when you're just looking at HTTP messages on a page, and then you don't see how this stuff scales, right? Because scaling anything ruins all your previous decisions. When you realize you have to scale it, you realize you need to make totally different decisions. So we're gonna see all this stuff. So our base architecture is gonna have 1,000 users, and they're going to be making 3 transactions per second on their mobile devices and across their various different things. So that's going to result in 3,000 transactions per second coming into the front gate. Okay, we've got something in the front like an Nginx or a gateway of some sort, and then on the other side it's a microservices architecture, and there are 4 hops. So we have to have 4 calls before we can send a complete response back to the user. Okay, so no security at all. We're talking about 3,000 TPS coming into the front door. That's 12,000 TPS on the back, because there are 4 calls, so 3 times 4. And that's our overall architecture is basically 15,000 TPS, right? And that's with 1,000 users. So that's what we're measuring everything against. Okay, so basic auth and its problems. This is an incredibly secure security technology. This thing in the middle there, that's called base 64. I'll say it really slowly because I know it's a very new concept for most of you. And it's totally secure, and no one has ever figured it out unless you've gotten past their first year of computer school. You know, I mean, so this dates back to, like, you know, very, very early days of the internet, and it's lasted so many years because I think a big sin of things that have tried to replace it is they get really too complicated too quickly, and so they don't stick around long enough to just push away basic auth. So here it is, still with us, very popular, but not the best thing in the world. Okay, so basic auth is, of course, just the username and a colon, and the password base64 encoded. That's it. So if you see that on the wire, you just throw that down in a terminal and type base64-D, and there's the password. So it's not the greatest thing. Okay, so what happens in an architecture with basic auth? You normally have something like an LDAP that's verifying all the username and passwords. Okay, so if we have 3,000 transactions per second coming into the front door, and at that point you verify the username and password, you now have, by default, 3,000 transactions per second going against LDAP. So LDAP is basically a mirror image of everything you have on the other side. So if you've got 6 million users, you got to be able to support 6 million transactions against your, maybe not transactions per second, maybe per day, maybe per week, but you've got to support that kind of thing against that LDAP store. So it has to match completely all of your external traffic. Most people do not secure the traffic on the back end. How many people do secure the traffic on the back end? 3. Okay, that's about what I expected. Actually, that is mathematically, I don't know, like 2.3% of the room, something like that. If you do secure the traffic in the back end, and you pass the username and password from the gateway to all the microservices in the back, and each microservice has to make a call to verify the username and password as well, now you have 15,000 transactions a second going against LDAP. So we can see we're going very much in the wrong direction, and also we're passing around the user's credentials like crazy. So this is probably not the best thing in the world. So what happens then? A lot of people do IP whitelisting, and that was really fantastic in like the 90s and the 20s, and the double auths, right? But IP whitelisting is the art of a system administrator typing in an IP address into something that says this channel is allowed and other channels are not allowed. Who wants to be elastic? All right? Everybody probably wants to be elastic. If you fire up a new machine and it's on not a new IP address, you can't IP whitelist unless you've got like a team of network administrators who are there and their only job is to type in IP addresses as fast as possible. You could maybe outsource that to India, but it's still probably not the best usage of your money or your time. So IP whitelisting is how people have basically authorized what computers can call and talk to what computers in the back end, and it just doesn't work going into the next generation of elastic architecture. So IP whitelisting is crumbling, and without anything to replace it, you are now back into a wide open back end, and you don't want to do that. So this leads to, either way, if you're securing these things, it's usually point-to-point stuff that you're securing. So this server can talk to this server. But this is the kind of communication that happens. One server says to another server, hey, give me all of Joe's salary information. And that server says, sure, and just hands it all over, assuming that everything's been authenticated somewhere else. So this is toast, of course, no problem, because no harm ever happens on the back end, right? So anybody here who has worked for Target? Okay. Anybody here have contractors? Those people are definitely 100% trusted, and they do not come and go on a regular basis. And we do not definitely give them good information or access to our backend. But actually we do. So our backend is very unprotected in a majority of cases. And we're giving lots of people access to it, so securing the back end is just as important as securing the front end. Okay, so now let's say that we have our basic auth architecture, and we've discussed how it's standing up, but it's got its limitations. And some hackers from the evil country of Latveria wake up, which of course, who knows where Latveria is? Have you been? It's a Marvel reference, so that's where Dr. Doom is from. And so Dr. Doom gets his minions together and he sends them all flying at your front gate. And then, if they're doing 6,000 hits on you per second, and you have your 3,000 transactions per second going against your front gate, now you have 9,000 transactions per second going against LDAP. right? So it's very easy for some bad people to DDoS your LDAP system, bring down your site. And so it's a problem. And of course, people buy all sorts of expensive hardware to try and, you know, look for the big mobs of, you know, orcs and people with big clubs smacking at the front gate and back them away. But ultimately, it is a problem. Okay, so this is the world of basic auth that we're living in. OAuth 2 is a wonderful thing that's going, you know what? We got to get rid of all these passwords. So let's do it. Let's make a specification. Passwords are evil. Passwords are bad. Let's get rid of that stuff. We'll make a new standard, and we'll make it completely different, and it will solve everything. So let's see what that is. Okay. So instead of you having a password, we're going to make a token. For every time someone logs in, they get a token, and there'll be one token per device. And the awesome thing about this is if you lose your iPad, but you want your iPhone and your laptop to stay working, they just remove that token. I lost that device, so I'll remove that device's access from my Twitter account, and from my bank account, and from my other things. So that's great. And everybody has the ability to manage access on a per device level, which is really fantastic, and we have actually gained something. So this is really great. How this works, how OAuth 2 works, is that there's a very fancy thing called a grant process, which is a really great way of saying logging in. But they don't call it logging in the standard because that would be too obvious and you have to be confused in order to, one, get paid to be writing a spec, and two, sell software. You need to confuse people to sell software. If they understand what you're selling too much, they won't buy it because they think, oh, we can do that. So grant, so we have a grant process. The grant process is a remarkably innovative thing of taking a username and a password and putting it in form parameters and posting it to an endpoint. That's called a token endpoint. And then what you get back is the payload in the bottom, which is a JSON payload, and it has basically what's called an access token, and a refresh token, and an expiration time. So the access token is what you use to log in, and the refresh token is, you know, used to I'll show you in a second, to get another access token. So you've gotten your access token, which is this little thing, and it's called a bearer token, which is a very fancy way of saying the person who bears this token may pass. Which I guess maybe they really like Lord of the Rings or something like that, but that was going on while this was made, so I'm fairly certain that there was some relationship there. So we bear the token to the gateway that we're trying to get admittance to which we are trying to get admittance if we're going to be really fancy. And so you just send that same token on all your different REST requests, and eventually, bam, you get a 401. Now what happens is now we need to use that thing that we got called the refresh token. Okay? So now we're posting the refresh token to the same place we posted a username and password. And in response, we get an identical payload, which has another access token and a refresh token in it. We put the refresh token in our back pocket for later, and we continue to send the new access token on our future requests, and we're off and running again. And so what this does is it allows us to have that token expire at a date or time that we think is appropriate, and without prompting the user for the username and password again, we have means to keep recycling that credential that we're sending to the server. So it is more secure than basic auth in the sense that we're basically making a unique password for that device, and we're recycling it on an interval that's configured on the server side. So that could be every half an hour, that could be once an hour, that could be once per day. It could be that you let it live infinitely. If you let it live infinitely, you have a little more than a new password per device. But it's an option you have. How much do you want that thing to go? Okay, and the wonderful thing about standards is that everything's optional, so of course refresh tokens are totally optional, and how you implement them is not exactly standardized. So we're already like just a couple slides into OAuth 2 and we're hitting kind of some squishy gray territory here. A good OAuth 2 implementation will support refresh tokens, and they will support giving a new refresh token. So I've seen OAuth 2 implementations that do support refresh tokens, but they let the same refresh token live. So the access token's getting recycled, but the refresh token's not getting recycled, which is dangerous because it's going to keep appearing on the wire once every half an hour, or whatever the refresh rate is. And if someone eventually steals it, they're you. And if it never expires, they're you forever. And not only are they you, but they can also use that to get new access tokens, and they can give those to other people. So it's a very, very bad thing for there to be refresh tokens that do not expire. So this is a, of course you have access tokens, they should expire, but refresh tokens should also expire. So this is a checklist item that you ask your vendor when you're evaluating something. If you have a current vendor, ask them. If you have a team, if you've rolled it out, ask them about this. Go ahead.
Dave, what kind of IETF for advice? Is it the MAC address and part of the system being able to that?
What's that?
Yeah, what does it take to make the idea of device?
That's a fantastic question. The definition of what an access token looks like, there isn't one in the OAuth 2 specification. It's whatever the vendor wants it to be. And often, it's just a made-up string. So it doesn't have any information often about the person. So if I were to break up OAuth 2, in the first 5 years of OAuth 2, most of the implementations generated a random string, sent that across, and then when I had to refresh it, they just generated a new random string. And so what have we achieved when we do that? We have a lot more passwords now. So the funny thing about this, if you were to take and analyze what we accomplished, so I bet you nobody here is using forms to form posting in form URL encoded to log into a server, right? Nobody. That's brand new. None of us have been doing that for the last 15 to 20 years, okay? So far, we've taken form login and we've called it a grant. Great, so we've achieved confusing people. Awesome. Step one of being a good vendor. Step two, now, what did we get in return? We basically got a password. If someone sees it on the wire and they steal it, they can be that person for the time that the access token lives. So we've got a form login, which we already had, and we have a password now, which we already had, but now we have a lot more passwords, okay? And so we've taken password and we've renamed it to token. Awesome. So grant and token instead of login and password. Cool. So we've now renamed another thing. Now, the really gain that we have is the expiration on that, but a lot of OAuth 2 systems don't expire the access tokens. So we're not too far from where we were before, except we've basically renamed a whole bunch of things and confused a bunch of people. We gotta send people to training for a week to learn what they already know, because if we just lined up the words, grant, login, token, password, you're off and running, people would get it. But of course, we've got everything named differently. I like to refer to tokens as a slightly less crappy password, but it is an equally crappy HTTP session ID. Doing a form login and getting a small little string back that we have to pass with every request so that people know who we are is an HTTP session no matter how much you cut it. And so basically we haven't accomplished too much that we weren't already doing. And the funny thing is that a really great tactic that vendors like to use is to confuse you. So what's your solution for OAuth 2? What are you guys doing with it? And people are like, oh, we don't really know. We're still learning. We're still looking to that. And so it's a common technique to disarm people. If a vendor was honest and went in and you called the vendor and said, you know what, we got a lot of passwords, we want to get rid of passwords. And they said, I got a solution for you, way more passwords. You'd be like, get out the door. But that's what we bought. So that's OAuth 2, way more passwords. And everything is renamed. So how this works out is, of course, instead of having 1,000 3,000 passwords per second being sent to the front gate. we now have 3,000 tokens being sent to the front gate. And of course, that all starts with an OAuth 2 form login with the actual username and password, so that's still there. That happens, in our scenario, we're going to say that everybody logs in once a day with their username and password. From there on out, they're using access tokens and refresh tokens. And the refresh tokens are happening once per half an hour. Okay? So we have all of our people come in and they log in against LDAP. So we have 1,000 hits for the whole day on LDAP. And then we have our still 3,000 TPS. Now, instead of against LDAP, it's against our token database. So our token database now becomes a replacement for LDAP as the center point of failure. And of course, we haven't really achieved anything on the back end, because if this REST service sends this token to that REST service over there and says, give me all of Joe's salary information, here's the thing that represents the user, that service is going to go, what does this mean? And they're going to go, I have no idea, ask the token server. At which point, all the services in the back end are now calling the center token server again, so now we're getting an additional 12,000 TPS against the back-end token server, and we have effectively now, it catches on fire because it's now processing 55% of all traffic. That is a major scalability issue, and of course now we're getting 0 transactions per second because it's a center point of failure and it will eventually fail. So we moved our center point of failure, renamed everything we already had, and we have a ton more passwords. But we haven't achieved anything architecturally. Okay, so we have pointers and we have state. The token server is state and the tokens themselves are pointer. So what is a better name for access token? How about access pointer? That's a good name. Or access primary key, because that's actually what it really is. And if we called them those things, people wouldn't want them at all. It's all about marketing, right? Got to use something really cool in order to get people to buy it. Don't be too honest, because then they'll definitely not want it. No one would have purchased this at all. Imagine some people spent millions of dollars tearing down a basic auth system to put an OAuth 2 system up there, which basically got them a very lateral move at an identical architectural cost, plus having to maintain the previous LDAP architecture. So, you know, it has its advantages in the exploration aspect of it, which does make it more secure, but it doesn't really achieve much. So in the effort to rename something, I like to refer to OAuth 2 as high frequency password exchange algorithm, which is a much more honest thing, right? So if we want to go for honest terms, high frequency password exchange algorithm is a pretty great way to describe OAuth 2. Okay, so let's, before we get into the next section, let's ask a good trivia question. So I'm going to present a problem, and the problem is we have a set of files on a directory, and we want to know when the contents change. So yeah, we can use a directory scanner. We can look at the time of the file, see that it's been updated. We can look at the size of the file. So who says time? Who says size of the file is a great way to determine if it's passed? Who says use both? Okay, all right. So the correct answer is to hash it, right? So I like to describe hashes as basically, we have this snow globe, and inside the snow globe are ones and zeros, and they all start out as zeros. And as the data passes through, we effectively shake that snow globe, and then when wherever it stops, that's our hash. So it's, using another analogy, it's like having an abacus where all the things start at the beginning, and as the data goes by, you kind of shift things around by primary numbers using the information you see. So if you see a 1, you go this way, you see a 0, you go that way, you just keep doing that, and whatever that thing says in the end, that's your hash. It's magic, it's statistical magic. So basically what we have is a number that's statistically unique. And depending on how statistically unique, it is really how many bits you're using, right? So if you have a very short number of bits, it can't be very statistically unique, because odds are you're going to find somebody else with the same hash but different data. The larger that number gets, the more statistically unique it is, right? So we've taken in that, run our data through the snow globe, And of course, we crack it open, and that's our hash. And of course, do you like how the snowman's got a little tear? He's sad. We broke his house. It's for security, had to be done. Okay, and more bits means more secure. So we used to use 128 bits for a lot of stuff, and now we use 256, and soon, someday we're going to go to 512, and we'll just keep going because computing starts getting to the point where it can replay the data over and over and over again and come up with different hashes. By the way, Bitcoin is very fundamentally based on hashes. So it's a good concept to understand because if you put anything like blockchain in your product, you're going to sell way more. Or your company, even if you make film, which is amazing, but yeah. So let's present the scenario. We have this data. In this text file, we have Vikings beat Saints 29-24. I'm from Wisconsin, near Minnesota, so I think this is pretty good. You can see where I came out on this side. So that's the score of the game. And we put this in a text file, and the hashes for that text file in many common hashing algorithms are as follows. So by the way, there is actually a hash 64, or excuse me, I don't have it on here. Oh, there's an 85, by the way, a base 85. I'll come to that later. Who knew there was a base 85, by the way? Yeah, that was a Google one that I discovered. All right, so we have this file. It has this contents, and these are the hashes for it. But then the Saints, they try to pull an easy on us one, a big easy. I guess I would make a bad joke. I practiced that one for like all of 2 seconds in my head before I gave it. And they try to change the score because they don't want to lose by so much. They try to change it to 26-24. But if they do that, the hashes will be different. Okay? I guess I didn't paste the new hash in there. Anyway, so that's what I get for updating these things live. I try to make it topical. I gave this talk in Morocco, and I used like Morocco beats Ivory Coast 1-0, 2-0, and they applauded. It was fantastic. Okay, so the key is, if you don't want there to be some dispute about what the true hash is, you need some way to protect the hash. The hash is definitely going to show you that the content changed, but there's no way to say which hash is the authoritative hash, which one is the right one, right? And so in this scenario, you need to basically encrypt the hash. Okay, so there are two techniques for encrypting the hash. There is asymmetric and symmetric. Symmetric means the same key that encrypts the hash can also decrypt the hash. And asymmetric, you have one key which can encrypt the hash and another key which can only decrypt the hash. By the way, the key that encrypts it cannot decrypt it, and the key that encrypts it, that decrypts it, cannot encrypt it. I mean, you could if you chose to do it that way, but basically one of them you use to encrypt, and you call that one typically the private key, and then the other one you give away freely, and that's the public key. So how we would do this in this scenario is that the moment the score was called, 29-24, the ref would call the score. The ref has a private key, public key pair. The ref signs the score with its private key and hash it, sign the hash with the private key, put the private key in the back pocket, and then the whole stadium gets the public key, and from there on out, everyone can verify the score, and no one can lie about the score because everybody has equal ability to verify the truth by checking it with the public key. And the ref keeps that private key in the back pocket and maybe uses that in several games and changes it once a year. So that's how you would use that in a real-world scenario to tell a truth from a lie and prevent people from manipulating the truth. So this is what we're effectively going to do with OAuth 2. And I don't know how, we're an hour in, so this is probably the great time to take a break before we get into it. But here's just one thing. A lot of people, hashes are becoming a very commonplace thing, and we're seeing them everywhere. GitHub has hashes as the commit IDs because it's a great way to make a unique number out of thin air. You don't need a reference, you don't need to count up from a certain number. They take your current commit, they take the previous commit, they hash it together, boom, and they take your commit diff, and they feed that in, they hash that data, and that's your commit ID. And so it's a very great way to come up with a stable, reproducible number that is very statistically unique and great enough to even make a distributed version control system from. SVN, GitHub, Git does not have a center server that issues IDs. It's made dynamically on your machine using hashing. So most people are used to seeing these little hex things, and they think of hashes as a string. But a hash is actually just a representation of binary, and that same binary number, here's a number in binary, that's that same number in hex. And that's that same number in base 64, and that same number in base 85. So there's the base 85. Obviously, the more things you get, the shorter the string gets. But that is what you should, if you understand nothing else, if the rest of the talk is confusing, if you understand this much, that to protect data from being tampered with, you have to hash it. And to protect the hash, you have to encrypt it. And to make sure that that's secure, you have to protect the keys that encrypted it. And if you want other people to be able to verify it, but not also make hashes, then you need to use public-private key, and keep the private key and distribute the public key. And all security, the Amazon style and the Google and Facebook JWT style, all use this concept. SAML tokens use this concept. A lot of Kerberos stuff uses this type of thing. So all the really good security techniques are fundamentally based in hashing data, encrypting the hash, and protecting the keys, and distributing them under certain conditions. So that's a great place to take a quick break, and we will come back and we'll see how we are fundamentally able to change OAuth 2 once we get back. So go ahead and take a break, and if you want to not take a break, now's a good time to ask questions.
So we have to use OAuth 2 to talk to one of our vendors for their REST services. And one thing that's caused confusion is we have a cluster trying to talk to their system. And just each node in the cluster gets its own token? Or how does that usually done?
Well, with OAuth 2 as the way it's done here, it doesn't scale. So effectively you have a cluster like microservices architecture before was called microservices architecture. You have many machines back there, all of them need to verify identity, and if they're handed a token, they got to turn around and ask somebody what it means, and it sends a lot of traffic to one single place, which then becomes your next scalability issue.
Okay, but I'm talking about mobile machines on the outside calling in.
They would have to, well, if there's a user on the other side, and that machine has collected username and password and done the login, that's one thing. If they haven't, and they're given a token, then they're in the same position on the outside having to verify the token. So the token has no data, and it's only true in reference to something, and you got to go ask the something if it's true. And so it's a trip, it's a network hop, guaranteed. Go ahead.
So my question is, with the refresh token, how does this ever expire? I mean, what if the password changed or the person, this can just go on forever?
Right. So you typically need, so the question was, how does the refresh token, how do you log somebody out?
Yeah.
You know, how do you effectively log somebody out? So you have to look for an implementation that's fairly robust in handling these tokens. And so one approach is that you could say, I only allow them to refresh for 30 days. And after 30 days, no matter if they come back in with a refresh token, I'm not going to honor it. That requires you to track on the back end a lot of state, because it's not in the token. So
And it's not part of OAuth 2.
That's all very advanced stuff. That's, you know, refresh tokens in general are optional per the OAuth 2 specification, which is disappointing. And how I've seen them implemented in the real world varies quite differently. And so the advanced aspects of handling refresh tokens, and forcing people to log in once in a while, you find only in a small percentage of the products out there.
Passwords you have to enter, right?
Right.
Your session expires, you got to
Right.
enter it.
So one technique that people do is say the refresh token lasts for, if the access token lasts for an hour, then the refresh token lasts for at most 8 hours. And if they don't use their device continuously, if they haven't used their device continuously for 8 hours, they're logged out. So they come in the next day and they gotta log in again. But if they worked all night, they're not logged out. So that's one technique that people use. But if you have a very long period of time, like 30 days, probably people are going to be using their stuff fairly regularly, and then they're effectively never logged out. So some products, our product, for example, just to mention it without dodging the question, we allow you to specify what the policy is for the refresh token. Yeah, we can say, how many refreshes do you want to do? Or do we push out the login date another 8 hours after every time they come back? So therefore it could be infinite. Or do we cut it off at a certain number of days, no matter what? They could be in the middle. It's all up to the vendor.
So I've looked at this stuff for years. You guys kind of look at it. What's the concept of just getting some of these stuff in a token?
That's the next part of the slide. Yeah. That's JSON Web Token, which is basically kind of the inverse concept.
So if you have to encrypt the hash when you're transmitting, especially when you're transmitting it to the backend to verify that the token wasn't modified.
Right.
If you're basically doing that from like for example, a native mobile app, does that mean that you have to put the private key inside the native mobile app?
You would put the public key, but I'll show that in the next part. So that's the answer. I sort of gave everyone all the information to solve the problem in their head, but I'll paint a perfect picture of that. But yeah, short answer is no, you do not put the private key on the mobile device. You put the public key if you want to verify anything on the mobile device, or you put nothing on the mobile device, and they use it just like a regular access token. They go, this is my private thing that was given, I should keep it private, I'll send it, and on the back end you verify it.
What about you need to encrypt? Would you need to encrypt the let's say the user ID and password when you send it to the server?
You still have to use SSL for all of this stuff. Yeah, you can't send anything in clear text.
But don't you want to encrypt the body before you send it across SSL?
Well, you may want to, but OAuth 2 does not have means to separately encrypt anything. So you just use a regular TLS or SSL, and then you send your regular form parameter login over that, just like you would have done in the last 15 years. And so OAuth 2 is identical in the login process as we've all been doing. And that was a strategic decision because they wanted to fit something into architectures that already existed and clients that already existed. They didn't want to have too much code change for people so that it could have a higher chance of being adopted. So I painted it as bad, but it actually was a fine decision to make. But no, there is, as a result, no fanciness for encrypting anything on the login process.
Because for some OAuth implementation, you also have to embed, for example, the API key inside the client.
That is an option. So I kind of glanced over it, but you can on the login have. There we go. Well, I didn't put it there, but in the form parameters, you can have client ID and client secret is basically a way to give the app itself a separate set of credentials. Now, it's false security because if you put that app with the credentials in it in the app store, then everybody has it. And so but it does give you some way to identify the app coming in so you can maybe treat them differently. So it's fine. If you are not publicly distributing the app, then it's secure. If you have some third party that they're the app and they're keeping those credentials secure, then you can definitely give the app set of credentials, and then the app collects credentials from the user and sends both of them over, and you go, yes, that's the person who says they are, and yes, that person is authorized to log them in. So that's another way to handle a third-party person logging in people for you is effectively you issue them also a set of credentials, and both sets of credentials are required for an access token to be issued. Go ahead. What's that? They're not typically used in OAuth. You know, identity certs are pretty great if you can get away with them. The problem is that they terminate at gateways and devices like that that terminate SSL, and the identity is then lost when a new SSL channel is established on the back end. So it's really difficult to propagate identity, although they're, in security terms, super strong, but only for the duration of the pipe. Yeah.
So if I don't want to have username and password login, it's not a user, it's a business. I think it's where you get the BTP systems later.
Yeah, so I'll show that. There's an alternative to identity certs because they're great. If you can get away with them, they're fine, but propagating information about the caller is a trick. At a certain point, it's blind trust. You know.
So it's
similar, yeah. I mean, unless you turn around and take that token back to the server who generated it and say, who was this? And they can tell you authoritatively, you know, then it's not blind trust, but now you're generating a whole lot of network traffic.